Hello students, welcome back to the session. I am your tutor Syed. Let's get started with the session. The question is, if vector f is equals to x plus y plus az times of I plus bx plus 2y minus z times of j plus x plus cy plus 2z times of k, find a, b and c such that curl of vector f is equals to 0, and then find phi such that vector f is equals to del phi. So it is given that curl of vector f is equals to 0, which means that vector f is irrotational. If vector f is irrotational, then we need to find out the values of a, b and c. So let us start the solution by taking vector f to be equals to 0. That means curl of vector f is equals to 0. So let us write down the determinant. The determinant is I, j and k. Then the second row, the coefficient of I in del, as we know that del is equals to dou by dou x of I plus dou by dou y of j plus dou by dou z of k. So coefficient of I is dou by dou x. Coefficient of j is dou by dou y. Coefficient of k is dou by dou z. The last row vector f here to take, and coefficient of I is x plus y plus az. Coefficient of j is bx plus 2y minus z. Coefficient of k is x plus cy plus 2z. So this determinant is equals to 0. Now let us try to expand this one along the row. So this is plus, this is minus, and this is plus. So if we try to expand this one, we will be getting the expression as plus I times of. So you have to close the column and row. Close this particular column and row. Now we need to multiply this one. So dou by dou y of this value into dou by dou z of this value. So you will be getting dou by dou y of x plus cy plus 2z minus, it is dou by dou z of bx plus 2y minus of z. Now take the next value, minus of j times of. So now you have to close that column where j is and the row where j is. Then you try to multiply this dou by dou x of this value, dou by dou z of this value. So therefore we'll be getting dou by dou x of x plus cy plus 2z minus dou by dou z of x plus y plus az. Now let's take plus k times of. You have to close the column where k is and the row where k is. Now cross multiply this one, dou by dou x of this value and dou by dou y of this value. So it becomes dou by dou x of bx plus 2y minus of z minus dou by dou y of x plus y plus az is equals to how much? Is equals to 0. Let us further try to simplify this one. Plus I times of, you differentiate this with respect to y partially. When you are trying to differentiate with respect to y partially, then x and z are constant, which means this x is also constant, this z is also constant. So derivative of a constant will be 0. Plus c times of derivative of y with respect to y is 1, c times of 1 will be c, plus z is a constant, 2 is also a constant, so 2z is a constant, its derivative is 0, minus. Now next term that you are having is dou by dou z. That means you have to differentiate partially with respect to z. When you are trying to differentiate partially with respect to z, this x and y are constant. Therefore, the derivative will be equals to 0. So bx is a constant, derivative is 0. 2y is a constant, derivative is 0, minus derivative of z with respect to z will be 1, minus j times of. Now further we have to differentiate partially with respect to x. If you are trying to differentiate partially with respect to x, this y and z will be constant. So derivative of x with respect to x will be 1, plus cy is a constant, derivative is 0, 2z is a constant, derivative will be 0. Now minus, further I have to differentiate this partially with respect to z. When I'm trying to differentiate with respect to z, this x and y will be constant. Therefore, its derivative will be equals to 0. Second term is also 0, plus a times of derivative of z with respect to z will be 1, plus k times of. Now we have to differentiate with respect to x over here. Therefore, this y and z is a constant. So b times of derivative of x with respect to x will be 1, minus 2y is a constant, 0, z is a constant, 0, minus you are having dou by dou y. If you're trying to differentiate with respect to y, x is a constant and z is a constant. Therefore, derivative of a constant will be 0. Derivative of y with respect to y will be 1. Az is a constant, its derivative will be 0. Is equals to how much? Is equals to 0 we have. Further, let us try to simplify this one. Plus I times of, you are left out with c here, and minus of minus will become plus 1. Minus j times of, you just left out with minus of a here, plus k into, you left out with b, and this is minus into plus will become minus 1, is equals to, you have 0. Or if I want to rewrite, first I'll write the value c plus 1 into I, minus of minus will become plus a into j plus b minus 1 into k, is equals to 0. So this represents 0 vector because curl of vector f is vector. Therefore, you can write 0 times of I plus 0 times of j plus 0 times of k. Now let's try to equate the coefficients of I, j and k. Equate coefficients of I, j and k. So if you equate the coefficients of I, that is c plus 1 will be equals to how much? Will be equals to 0. So that's the coefficient of I. So this is the coefficient of I. So now further c will be equals to plus 1 goes on this side, becomes minus of 1. So we have got the value of c to be equals to minus of 1. Let us equate the coefficient of j. So j coefficient over here you are having plus a, and over here it is just 0. Therefore, a will be how much? A will be equals to 0. So we obtain the second value. Now let us try to equate the coefficient of k. Let us try to equate the coefficient of k, this one, coefficient of k. So we will be getting b minus of 1 to be equals to how much? 0. Or b will be equals to minus 1 goes on this side, becomes plus 1. So we have got the values of a, b and c. So a value is 0. Here value of b is 1. The value of c will be equals to minus of 1. So first part of the solution is complete. Now we need to find out the value of phi. So to find out the value of phi, we know this result. We know del phi is equals to vector f. So del phi is dou phi by dou x into I plus dou phi by dou y into j plus dou phi by dou z into k is equals to vector f. So vector f is already given in the question. This x plus y plus az times of I plus bx plus 2y minus z times of k plus x plus cy plus 2z times of k. This is j. Now let us try to equate the coefficients of I, j and k. Equate coefficients of I, j and k. So let's start with coefficient of I, that is dou phi by dou x is equals to x plus y plus az. And then you have coefficient of j will be dou phi by dou y is equals to, it is bx plus 2y minus of z. Then coefficient of k is dou phi by dou z is equals to x plus cy plus 2z. Now since we know the values of a, b and c, let us try to plug in the values of a, b and c. So a value is 0, b value is 1, c value is minus of 1. So if you plug in, you'll be getting the value as dou phi by dou x is equals to x plus y, because a is 0, 0 into anything will be 0 itself. Next we have dou phi by dou y is equals to, b value is 1, so 1 times of x plus 2y minus of z. Then you have dou phi by dou z is equals to x, c value is minus of 1, minus into plus will be minus y plus 2 times of z. Now let us try to integrate this one. There is integral of dou phi by dou x, where integrate with respect to x is equals to, it is integral of x plus y into dx. So let me take this as equation 1, this as equation number 2, this as equation number 3. So dou phi by dou x integral will be just 5 is equals to, now here integral of x into dx will be getting, y is a constant outside, it is integral of dx. But whenever you try to integrate, you have to add the function of the constant. So it is function of, because x is the variable, y and z are constant, function of y and z. Plus you'll be getting f of y and z. There is nothing but integral of x will be x square by 2. Y as it is, integral of dx will be x, plus it is f of y comma z. So we got 5 value. Let me take this as equation number 4. Now go back to equation number 2 and integrate it. Integrate equation number 2. Integrate equation number 2. We'll be getting integral of dou phi by dou y into dy is equals to, it is integral of x plus 2y minus z. X plus 2y minus of z times of dy. So here constants are z and x. Now if you try to integrate, dou phi by dou y is 5 is equals to, so it is x is a constant, it is integral of dy. Then plus 2 is a constant outside, then you have integral of y into dy. Minus z is a constant, you have integral of dy. Plus f of z comma x. Now further let us try to integrate this one. You have x into integral of dy is y plus 2 times of integral of y is y square by 2 minus z into integral of dy will be y, plus you have f of z comma x. You can observe this 2 and 2 will get cancelled. You are left out with xy plus it is y square minus zy plus f of z comma x. We got the second value of 5. Let me take this as equation number 5. And again, let us try to integrate equation number 3. So equation 3 is integral of dou phi by dou z into dz is equals to, it is integral of, so dou phi by dou z value is x minus y plus 2z times of dz plus function of, here x and y are constant, so f of x comma y. So this integral dou phi by dou z integral is 5 is equals to, x is a constant, you have integral of dz, minus y is a constant, you have integral of dz, plus 2 is a constant, you have integral of z dz, plus you have function of x comma y. So this is nothing but x into integral of dz is z minus y into integral of dz is z plus 2 times of integral of z is z square by 2 plus you have f of x comma y. We can observe that this 2 and 2 will get cancelled. You're left out with xz minus yz plus z square plus f of x comma y. Let me take this as equation number 6. Now we need to compare these equations. We'll start comparing equation 4 and 5. So here 4 and 5, which are the common values that you have? X, y, that is the only one common value, x and y. Other values are not there. So what about this x square by 2? That should be there over here. Because x term is there, we'll be getting x square by 2. And then, so x square by 2 you have taken. But here, what are the additional terms? Y square is there. So this term has to be containing y square, right? So y square is done. Then yz, we are not compared. So minus yz, minus of y into z. Now if you try to observe 1, 2, 3, 4 terms are there. Here also 1, 2, 3, 4 terms are there. So equation 4 and 5 are compared. So comparing equation 4 and 5. Comparing equations 4 and 5, we get the value as f of y comma z is equals to y square minus yz. Y square minus yz. Then you have f of z comma x. What is the value of f of z comma x? The square by 2. Now let us try to compare equations 5 and 6. Equations 5 and 6. So let us try to observe over here what are the values that you will be having. So x into z, x into y is not there. X into z, none of the terms are visible over here. You can observe the z into y or y into z. Both are the same, right? Other terms are not matching over here. So let us write down what are the other terms that has to come over here. So this xy has to come. So let us write down xy will come over here. Xy. Then y square is not there over here. So plus y square has to come over here. Minus zx is already over. Then x square by 2. So x square by 2 has to come over here. Plus x square by 2. So what are the other terms that are missing over here? Xz you have. Xz is not there. So plus xz has to come here. Or zx. So this is over. Then plus z square has to come. Z square will write down. Plus z square. The same terms have to be updated here also. Over here. So y square minus yz you have. Plus x square by 2 was there. Zx. Z into x you have to get plus z into x. Plus z square is not there. So plus z square. So totally how many terms? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 and 6. So all the terms are there. Now if you try to compare this one. Here also you can see 1, 2, 3, 4, 5, 6. So comparing 5 and 6. So remaining terms you can write down over here. The terms which we are missing. So totally 4 terms you will be getting over here. It is y square minus yz plus zx plus z square. What about this f of z comma x? So you have x square by 2 plus zx plus zx plus z square. Now if you try to compare, which value we need to write? I have to write only f of x comma y over here. What is it? Plus y square plus x square by 2. So now if you write down the final solution, so you can write this equation 6 itself as the final solution. Whether you write 4, 5 or 6 equation, all are the same only. Write down, therefore, the scalar potential will be scalar potential phi will be equals to how much? It is xz minus yz plus z square plus that function f of x comma y. What is its value? I've written here this one plus xy plus y square plus x square by 2. Or if I try to rearrange this one and write, so the value of phi will be equals to, So first I'll be writing x square by 2. Then I'll write y square plus z square. Then remaining values plus xy minus yz plus zx. Instead of writing xz, I'm writing zx. So this will be the required solution. That's all I have for today. Meet you in the next class. Till then, goodbye.